So up till now, we mainly looked at tropospheric pollution, which is both gaseous and particulate in nature. Now we will move higher up into the atmosphere, into the stratosphere, where there is an ozone layer present. First, we'll try and understand what the ozone layer does, and then we'll look at how this layer is being affected today. Sunlight has a lot of ultraviolet radiation that comes along with it, which is typically called UV rays. Now, if UV rays were to directly hit the earth, they would lead to cancers, cataract in the eyes, and different other aging related problems, and they're typically harmful for us. This gets blocked in the stratosphere by the creation of ozone. Let's look at how this happens. Whenever ultraviolet radiation hits oxygen, which is already present in the air, it splits up the oxygen into free radicals of O individually. These free radicals are typically very reactive because they're unstable, and oxygen free radicals further combine with the oxygen molecules present to create what we call ozone, which is nothing but O3. Ozone is typically thermodynamically unstable, and it tries to go back to create O2 and O separately, which is simply a chemical equilibrium with each other, and at steady state there is a fixed amount of each of these present in the atmosphere, and the creation of both of these use up the UV rays and do not allow the UV rays to come all the way into the earth. Now, if some chlorofluorocarbons such as CF2Cl2, why are they called chlorofluorocarbons? Chlorofluorocarbons. If they get released into the atmosphere, they start affecting the ozone layer. First, let's try understanding where these come from. CFCs are typically present in a lot of compressors which are used either in air conditioners, refrigerators, etc. And due to in some or the other ways, they can always get released into the atmosphere. If they reach the stratosphere, then the ultraviolet radiation starts affecting the CFCs, and it splits this up into free radicals. The moment the free radicals are formed, they are unstable. They try to react with whatever they can find. Now, in the stratosphere, what is present? Ozone is present. So Cl free radical reacts with ozone, and ozone is also unstable, so they're happy to react and create a more stable product. In this reaction, one of the O free radicals combines with Cl free radical to form ClO free radical. Why? Because oxygen should typically pair with two elements. It's paired with Cl, so it's got one free radical present, and oxygen, which is fairly stable. Now, ClO is still unstable and still needs to react. It wants to react, and what else is present in the stratosphere? There's oxygen molecules, there's O free radicals, and there's ozone. It reacts with O free radicals. Both of these combine to form oxygen, which is stable, leaving chlorine back again as its free radical form. We saw that chlorine free radical, which is already present here, would react with ozone to take this process forward, which would create to ClO. Cl free radical is creating ClO free radical. ClO free radical is again creating Cl free radical, and this cycle will keep going on. Now that is okay because there will be some Cl free radical created, then it will get used up again. There will be some ClO free radical created, it will get used up again. So no problem. The problem is ozone keeps getting used up in this process, and only oxygen keeps getting formed, which means all the ozone that was present in the layer at that point of time starts getting consumed up here, which is why we call it ozone layer depletion. And if the amount of ozone present in that layer reduces, then ultraviolet rays start penetrating through and go all the way up to the earth, and they can cause several problems. They affect humans, fish, plants, etc. and they're extremely harmful to day-to-day life.